Okay, sorry about that. I hit the wrong button. I just have a couple of minutes to go, but I hit a button that, anyway, doesn't matter. So I'm shifting gears here a bit, and this is from the law, the policies that guide Endangered Species Act. And this is a 1996 policy seal, so let's bear in mind that this predates a lot of things besides allozyme. So there wasn't that much going on in terms of applying genetic tools to conservation outside of allozymes, and that's a pretty clumsy tool. And so we've thought a lot since then about distinct population segments and what can and can't be listed under the Endangered Species Act. And so here's the 1996 policy. International boundaries are not appropriate in determining that a population is discrete in the draft policy. Now I should point out that may go in direct contrast to the listing of the California gnatcatcher because the main thing there does indeed seem to be an international boundary. Political boundaries other than those between nations may be appropriate in some cases to delimit DPSs, and so maybe I don't know what that means. Political boundaries other than those between nations may be appropriate in some cases to delimit DPSs. And I guess this may hearken to the timber wolf, which is there's nobody making the argument that wolves in different states are genetically distinct and evolving independently from one another, and yet the service has delisted wolves in some states where the populations are doing well and not in others. Complete reproductive isolation should be required as a prerequisite to recognition of distinct population segments. And this is becoming very, very difficult because with the advent of more sophisticated genetic tools, we're seeing lots and lots of cases where we see a good, healthy genetic distance between populations, and we presume then that's complete reproductive isolation, but we're not entirely sure. DPSs should be used sparingly, etc., etc. So there are not that many species that have DPS listings, and so here are the 18 animal species. 11 of them are domestic, 7 are foreign, that are counted more than once in the ESA, primarily because they have DPSs, and they may have more than 2 DPSs. But look, obviously, salmon, 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 salmon. So there's some salmon. There's the tiger salamander, in which are subpopulations. Piping plover, roseate tern, another salmon, steelhead, and then a couple sea turtles. And then you look over on the international side and you see an ungulate, ovis ammon, caiman, chimpanzee, crocodiles, dugongs, leopards, sea turtles again. So has been used sparingly in this case, but it may be the case that there's evidence to use it more frequently than we had presumed. So here is a paper from Schaefer, etc., where you see the northern phylogeny of the red and yellow-legged frogs, and you see the mountain yellow-legged frog is distinct from this whole other group in which the mountain yellow-legged frog, the foothill yellow-legged frog, is distinct from is paraphyletic with the mountain yellow-legged frog. And the 2 red-legged frogs, the California and the northern, are separated by the Cascades frog. So name-wise, common name-wise, this group is a mess. And you see that there's that there are cause to list some of them, but not all of them. And so this is the kind of case where you can see the use of the DPS would be valuable. Okay, I just wanted to finish up by saying that there have been a couple people, Fred Allendorf for one, and Oop Uberg, who both looked at this, thinking about genetics versus genomics and evolving our evolving tools for conservation. And so Fred Allendorf, of course, started with allozymes, a big genetics guy. And all the blue boxes here represent things that we measure directly with genetics, population size, population structure, genetic drift, inbreeding, and that saying that with genomics we can start to look at things like migration rates and adaptation and loss of adaptive variation. Uberg has a different kind of approach to this, but a similar sort of message. Genetics looked at population size, drift, inbreeding, and sequence variation to try and infer fitness, whereas conservation genomics can look at that population as it interacts with the environment and to get a better idea at fitness. And so, again, I think the take-home message here for this is that genomics is rapidly evolving our capacity to think about subspecies level variation, and it's important to conservation. The concern or the thing to think about is, with very long and lengthening lists of endangered species and the movement towards protecting systems because we don't have enough resources to devote to individual species, one has to be cautious about what kinds of species and how deeply we're going to be using things like genetic tools to think about conservation and whether it reaches the kind of level of priority that we would expect for most conservation action. Okay, that's a little bit longer than 15 minutes, but there you go. See you tomorrow.